Alright, today is going to be the continuation of the web exploitation lecture from last time, because web exploitation there's a lot to it, and it's fun, and it's important for capture the flag competitions. So, first of all, news in the past week. The biggest one is the crack attacks against WPA2. It was a vulnerability that dropped on Tuesday. It has to do with a key reinstallation attack, which is not really an explored area in WPA2, but it affects a ton of clients. The worst affected is Androids, but it affects a bunch of Windows clients as well, although Microsoft patched it so far. But that's definitely the biggest news of the past week. Another news is there was a Subaru key fob vulnerability found. So you know how we talked about car hacking last week? Well, people are doing it, and they're doing it successfully. This one was a really simple one. So if you don't know how key fobs work, it uses a radio frequency, and then if you transmit on this radio frequency certain signals, it unlocks your car, or it opens your trunk, or it starts the car, or whatever. And it has to use radio frequency or something like that for that. And usually for security, the companies use an algorithm to create rolling codes. So the different frequencies that it transmits on, or the different codes it transmits, switch, and it changes based on a pattern in the car and the key fob, so they're matching. So Subaru has a really simple algorithm. Ideally, it would be a pseudo-random algorithm. So since computers can't really get truly random algorithms, they use pseudo-random algorithms, and they didn't do that correctly for Subaru. So one guy sniffed it, and then he was able to see the codes, and he was able to recognize a pattern, and then he was able to copy that algorithm. And then all you need to know is once you have the algorithm, you just sniff, and you find what code they're currently on, and you clone the key fob to match it, or something emulating a key fob. So then you're able to, once you've cloned it, you're able to do whatever the normal key fob does. So unlock cars, or start them, get into the trunk, or whatever. So that's kind of interesting. Upcoming CTFs and events, we have the Pwn to Win CTF, which is on October 20th. For some reason, it's really weird time. It's from 12:37 p.m. to October 22nd on 12:37 p.m. But if you want to do that, you can. It's online, Jeopardy format. We have a Slack channel, so join it if you're interested. There's also going to be a War Games movie showing in the JC Cinema on October 21st. That's this Saturday. The doors open at noon, and the movie is going to be from 1:30 to 4 about. There's also going to be an Intro to Linux workshop. You guys probably don't need to do that if you've been to earlier meetings, but Michael's going to be running that on Sunday. Alright, so the plan for today. In Web Exploitation 1, we went over command injection, cross-site scripting, cookie manipulation, and simple SQL injection. So if you missed that, you can go back to that PowerPoint, or you can just ask me questions once we get to the practical part today. But today we're going to go over the brute forcing, unrestricted file upload, unrestricted file include, and blind SQL injection. So first thing we're going to go over is brute forcing. So basically if you have like a login box or something like that and you want to brute force the password, brute forcing is trying all different possible combinations. There's a difference between brute force attack and a dictionary attack. Brute force attack is trying all different combinations. A dictionary attack is trying all different words in a dictionary. So for example, if you're trying to brute force a password and you're trying to brute force the password of it, you usually have an ID of the username, and you can get that by, it's usually going to be admin or administrator, or if you don't want to try those, or those you can't get for some reason, you can try common names or names of an employee at the company or challenge that you're going after, and you could use a word list for that. So basically it's a list of those names, and then it tries all the different combinations for a password on those names. But obviously that makes it take a much longer time. Hydra is a really good tool to brute force remote logins. You can also just write scripts for it in Python, but Hydra, it's installed by default on Kali and our Mason Competitive Cyber virtual machine. And we'll go over that, how to use that later. So here's an example. Right now we're going to be going over damn vulnerable web app. And again, except we're doing the vulnerabilities that we didn't do in the last talk. So this one is the brute forcing one. You can see a picture of it. It's just a login box with the username and password. So in order to figure out how the login works, all you have to do is go to brute forcing. So let's try admin A. Incorrect. So if you want to figure out how this works, you open up Developer Tools, which you should have installed on your browser. It could work in Chrome as well, although I'm using Firefox. You go to the Network tab, and then you try it again. As you can see, it's just a GET request every time, an HTTP GET request every time you're entering a username and password. So, in order to brute force this, you have to repeat that GET request with the same headers and parameters, and then instead of, because in this case, as you can see, I use the username, admin, and password yeet, but if you change that to admin and a list of the top 500 passwords or whatever, then that's how you'd be able to attack it. So you can do that with Hydra. Huh?
Or if there's a temp limit.
Yeah, then that's a problem. That would be a method of counteracting brute force. But in this case, at least at the low, in Damn Vulnerable Web App, there's not. So you can use Hydra for it. I mean, you could write a Python script with the request library and just repeat that get request with a dictionary of the top 500 passwords, or you can use Hydra. Hydra does that by default. All you have to supply it with is an IP address that you're sending it to. So in this case, it's the IP address of Damn Vulnerable Web App. And then -L is username list. In this case, we're going to use -L and admin, because we're only going to try admin because we know admin is the username that's on there. Then -P, your password list. You can use RockU. You can use any of the default ones on Kali or the Mason CTPM. Then the form parameters. So in this case, it's an HTTP GET request, and then the failed logon message, so it knows where to replace the username and password. So right now it uses the carets character, and then if you put user and then carets are on pass, and that's where it'll replace from word lists. So in this case, instead of user, no, you could use user and admin, or you could delete this part and just put admin here. So that's how you do that one. It turns out that it's admin and password, so you could have just guessed that. That's another way to do it in competitions or real life. But if it's anything other than really predictable, it's much better just to try brute forcing. We're using a word list. Okay, so for unrestricted file upload, that's when, let me show you. So when you have something like this, where it says, upload an image, and you can browse your computer to upload something. It's what happens when, instead of uploading an image like it tells you to, it doesn't restrict what kind of file that you can upload. So you can actually upload malicious PHP. And I'm not going to use Metasploit for the examples, but if you're actually bad, you can use Meterpreter to create a reverse shell and then upload that so you can have a terminal. That's what happens. It's a reverse shell. It calls back to you. You can have a shell on the web server. So this is the PHP of what's happening on Damn Vulnerable Web App when you set it to low. As you can see, it's just post and and then it uploads it to hackable/uploads, and it doesn't check at all whether it's a JPEG or a PNG or anything, and it just uploads it no matter what you do. So what I did is I created a little PHP file. Instead of writing a reverse shell or anything like that, I just had it echo bushdid 911. And so that's you don't actually have to know PHP that well to write a PHP shell. You can use existing ones, or you can just have it echo something if you're trying to test. So then once I uploaded shell.php, it allowed me to. Then I could go to Damn Vulnerable Web App, that IP/hackable/uploads, because remember that's where it's stored, /shell.php, and it was there. It echoed it. It worked. So if I would have had a reverse shell instead of that, it would have been a terminal. And you can create a reverse shell with MSF Venom. That's an example command on what to do. In this case, it uses port 1337, and you would have to rename it as shell.php before uploading, and you'd have to specify the IP. Okay, but what happens if they if they actually filter for it and they actually check whether it's a JPEG or a PNG, what would you do? What do you think you would do in that case? Trying to get your PHP file to upload, but they're checking to see if it's appended with JPEG or PNG. They're not actually checking the file itself, they're just checking the extension.
You just name it to give it an additional extension.
Yeah, you just add it. So it'd be shell.php.png or shell.php.jpg. But then if you upload that, it wouldn't work immediately. You'd have to intercept it with Burp Suite, which is a web exploitation framework, and then you'd have to rename it halfway when it's sent. So otherwise it wouldn't execute because the server itself would think that it's a JPEG. All right, so we went over file upload. Now this is file include. It's different. There's two types of them. There's local file inclusion, which executes a file on a server. So let me show you the example on Downloadable Web App. If I click on file1.php, see in the URL, you can't really see it that well, but you see in the URL, it says page equals file1.php. A file inclusion vulnerability is when we change this file1.php and it executes something else. So if it's a local file include, then it executes any other file on the server. So I can change file1 to whatever I want, and I can use ... and to navigate the command line as long as I input it into the URL, like ... whatever. Or I can just start from root if I want. But it only executes files. So it's kind of like command injection, like we went over last time, but instead of doing any command you want, it executes the file that you're specifying. So the input is the file path in the URL. And then there's remote file inclusion, which is the other type that executes, instead of just files on the system, it executes files on any remote server. So you input a URL and it'll get that URL. So that's way more dangerous because you don't have to rely on what they already have on the server, and you can have your own malicious PHP. So here's an example of the PHP behind the file include on Damn Vulnerable Web App. As you can see, what do you think? Is this local or is this remote for file include? Would the input be a file name or a URL or both? So remember, there's two types of file inclusion. So there's the local one, which executes files on the server itself. And then there's the remote one, which if you change the file name in the URL, it'll go get that file from a remote website. So you think in this PHP, for this file, do you think it's a local one or a remote one or both? It's actually both of them. If you see these ... and /, that's the local part. And if you see the HTTP and HTTPS, it supports SSL. That's all right. At least there's that. It gets it remotely. So you can see this. It's I changed the URL. It used to be file1. I changed it to Etsy hosts, and then it echoes it back on the top. So /Etsy hosts. It's right there. So that's the local part because it's executing a file on the system. And then there's the remote part, which if I change it to HTTP google.com, gets that. So how would you guys try to make this malicious? If you can get any file on any remote server, what file would you try to get on the system?
Your own.
Yeah, so the same thing that we did last time that we were trying to upload, this is just another way of getting it onto the system. So you could host your own malicious PHP file. So instead of google.com, it could be your own server / something evil. So in this case, I just had it call itself, like remotely though, not locally, and get the thing that I uploaded before, which was shell.php, and it echoed back, Bush did 9/11. So you can execute it even if it gets it remotely. In this case, it's not the best example because it's reaching itself remotely. So you could have done that locally as well, but just pretend that this IP is your server. Or you can use popular web shells. This is not super useful in competition, but this is what attackers will do, is they'll use things like the C99 web shell, the China Chopper, WSO, or B374K. Those are the most popular web shells that I've seen before. And they can do a lot. They can do a lot more than just having a shell on a system. So you should check out how those work if you're interested in reversing it all, or web exploitation. So the last technique we're going to go over today is blind SQL injection. So we went over SQL injection before, which is executing SQL queries, SQL commands that you're not meant to as a user. So in normal SQL injection, the one that we did last time, you get useful errors. If you're trying to do a query and something goes wrong, the error will say something useful to you. It'll say, oh, this doesn't exist, or something like that. But with blind SQL injection, you don't have that. If it's right, it's right. But if it's wrong, it won't give you an error message. It'll just do nothing. So really, it's a true-false thing. So that makes it a lot harder than normal SQL. So what kind of questions would you ask the server if you were only limited to true, false, or yes or no as an answer? And you could get like usernames or passwords or things like that. You could ask questions about that. Or how many users are on the system. What questions would you ask in order to get the username and password or something? Like you could say, oh, is this the password? But it'll say no, and then you'll have to brute force it. And that's a slow way to do it when you have this capability.
Could refine lines?
Yeah, so you could say, like, admin's password is greater than 5 characters, and it'll say true or false. And then you could refine it further once you have the exact character length. So you say admin's password is equal to 6 characters. It says yes. And then you say, okay, is the first character A, is the first character B, and then you could get the password that way, and it's much faster than brute forcing it. So this is an example of PHP with normal SQL injection. It's getting a first name, last name, and you can see this or die statement that is giving you an error. See, look, .mysql error. So this is the blind SQL, and there's a comment there that says removed or die to suppress MySQL errors. And then they also added an @ character, so instead of MySQL numRows, it's @MySQL numRows, and that also suppresses errors. So you won't get anything, you'll just get a true or false. Let's see if you can break in. So right now is the practical part. I put damn vulnerable web app at 34.224.39.136. The login is admin and password. The really important thing to do once you log in is to set the difficulty to low. By default, it's set to impossible. If you try to do any of the challenges like that, like some people did last time, because I forgot to say that, and it's going to be extremely hard, just that we didn't go over how to do it like that. So set the difficulty to low or medium, and go over the challenges. I showed you how to do them today, so I'd like you to do them yourself, so you can get the practice. And then if you go to go.gmu.edu/tctf, that's a typo on the slide, /tctf, you can go to our training CTF. I added 2 challenges. The first challenges that I added was level 1 of Google's foobar challenge, if you've heard of that. So basically, if you search a bunch of technical things on Google, like really simple technical things around like Java or Python or things like that, eventually Google, the Google page will like lean backwards a bit, and it'll be this cool animation, and it'll say, hey, do you want to take the Google foobar challenge? And they give you a bunch of coding challenges, and if you get them all right, supposedly you get an interview with Google. Yeah, so it took a while, but I finally got the foobar challenge. They finally offered it to me recently, although it errored out, so I was not able to complete it. I'm not a software developer anyway, so it's fine. But level 1 I thought was an interesting challenge. It's a coding challenge, and I added it to the training CTF under foobar. So I gave you the instructions as much as I could remember from them, and so you can check that out if you want a challenge from Google if you're a software developer. And then the other challenges I added is it's a cipher with a repeating key in the cryptography category on training CTF. So you can either do that or any of the other challenges if you haven't done them yet, or you can do damn vulnerable web app, any of the ones that we went over today or last time if you have questions about the things that we did last time.